news is we got our model. It works. We got it working yesterday, and we saw that it was training. So what I need to do is, it does take a while to train, because I only have a little teeny GPU over here. So we're going to start the training process. We're going to have the model get saved, and then we can start testing it. While the model is training, we're going to be writing the test phase. That's what we're going to do. We're going to go through the testing phase. That's the plan for today. I think we should be able to achieve that. That's a really easy goal. That's a really easy goal. We should be able to achieve that, no problem. All right, let's get going. Okay. We need to save the model. Let's see here. How do we do that? Custom data. Hey, Brother Saber, and welcome on in. Good to see ya. Happy Thursday already. I'm very excited for Friday and the weekend. Hope you are too. All right. I want to save the model. How do we do that? Okay, so we're going to use the same logic here. I'm going to retype it because I want to learn it. Hey, Developer Exotic, what's up? Good to see ya. We're going to be testing our AI model that we trained yesterday. In fact, we have to retrain it because we didn't save it. So we threw away all of the training data. Let us get to the saving. Let's do a save. How do we want to write the save the model inside? Let's find out. Let's just do it. Let's just do it around here. Let's keep it easy and simple. So before we train the model, we're going to see if the model already exists on disk. And then we're going to load it, or we'll train it. That's the plan. Okay. So where is our model defined at? Right here. Okay, the model's defined here. What we maybe should do is put the code here. Okay, so model file is going to equal our Lynette.pth. And we're gonna make it look good. Model files here, right there. And then we're going to do a model load state. Is there a better way to load the model? I'm actually curious about this. Is there a better way to load the model? I do not know. Let's find out. Let's find out. Is there a more modern way? Because this way, approach. I'm actually kind of curious about this because we're going off of the tutorial, and the tutorial, you know, it. A little bit old at this point, and it has bugs in it. We found bugs. Not just one, not two, quite a few. Quite a few bugs. Okay. Oh, there's a torch.save. Check this out. Okay. If you want to resume training, the newer practice pattern is to save the full checkpoint dictionary, not just the model weights. Torch.save on our model state and the optimize. Oh, okay. So we could use torch.save. Am I already using torch.save? Let's find out here. We are. So I'm already using torch.save. Safetensors. Torva, what's that? What are safetensors? Oh, it's a new file format. Got it. I know what you're talking. It's not new. That's been around for a long time. I've seen that one before. We should probably use safetensors, is what you're saying? Okay, let's use safetensors. Let's do that. Okay. How do we do that? How about safetensors? All right, we're gonna find out how to do that real quick. Yeah, we could load .pth file that way, even with safetensors. I'm checking the current source on safetensor guidance. Okay, let's see what we have here. Device CPU. Okay. I want to do this on the safetensors. I'm gonna try. If you want, you can rewrite your snippet into a version that tries safetensors first. Hold on. Okay. Safetensors. Oh, installed all our libraries. We're gonna do safetensors now because Torva said use safetensors. So we're gonna do that, and we're gonna do that here. Where's our model file at? All right, right here. All right, so we'll go. Let's bring our codex back real quick because we had this is the. We'll do the same thing except with load file and save file. Okay, model file looks like good. Okay, model file exists. Let's see, where's model file? Oh, it's a path. I want to use the other one that I was doing before, where we're just using OS. Do we have OS? Import OS. We'll do it like that. So we're gonna do it differently. Here we go. Custom data, operating system. Right here. That's what we're gonna use. Okay, let's type this out. Let's type this out. We're not gonna copy paste. We're gonna type it out because it's gonna help you memorize and get better. Let's get better together, you guys. Let's do it. Okay. So if operating system.path exists, and we say model file. No, not momentum, model. Model file. There we go. Then we're going to load the model, which is going to be a little different. We need to load we're going to do it this way. So state dict and load. Oh, there we go. Okay, so we're going to load the state dictionary first. Okay. So we'll go state dictionary equals load, and it's going to be the model file like that, I believe, right? We get that part right? I think so. Little easy one, easy. Oh, device CPU. Do we have to say device? We're just gonna say default. We'll just leave it at default. There's state file, and we're gonna go model dot load. Was it load state dictionary? Yeah, load state dictionary. State dictionary. We got our state dictionary here, like that. Is that what we want? Yeah, let's do that. Okay. I'm just gonna make sure this works. And this is going to be called safetensor. Oh, there you go. Really big file extension. I don't know if you ever have used a safetensor like that before. Safetensor. All right. That's just going to be the weights and biases right there. Weights and biases. Else, we're going to train the model and then save it. Do we need an else? What do we want to do? Else for, else we want to train the model and save it. Okay. But we have to do training. Train here. Let me think about how we want to do that. And then we want to save the dictionary. So let's do this. Save. And we're going to do, how do we do this? Let's find out. Oh, we just do state. Oh, in the model file. Okay. Save file. Okay. So this will be model dot state dictionary. Is it a function? Yes, function, comma, model file. There we go. Right there. All right. Easy, easy. Great. So we need to move the training logic there. How do we do this in our other one here? I'm curious about that. Save. Where's that at? Here we go. So train. Okay. So what we did was we put the epoch calculator here, which I like that approach. So let's do that. Let's do the same thing because it's clean. It's really clean. So I'm going to delete this and call this def train. Like that. And then we're going to put the train logic here like this. Train epoch. There we go. As thus we do. Lynette.epochs. Yes, there we go. I think we did it now. All right, good. Let me pull this over 1 second. I'm going to drop the epochs before. I'm going to drop it to 1 epoch because I want to make sure that it's going to save and load before we train it too hard, and then we're going to start the testing process. So what we're going to do is we're going to train this model in the background. Probably let's do 15 epochs. Let's do 15 epochs. Begin the training process right here. And now we're going to start writing the code tutorial, and we're going to start working on the test part. So this will be def test right here. Perfect. Okay. So let's go over here. All right. So continue on forward. So we did all of our losses. Yep, that looks right. That looks like the numbers we're getting. Let's do the testing phase. Where is that? Torch. Okay, so here's the testing phase, I believe, right? Torch max outputs data ops nat. Okay. Torch max outputs data. Okay, the max. Do you want the max or the argmax? We're doing something different. Okay. We cannot use this because it is not the same. We'll have to change it up because we're doing it different, you guys. Learning as an AI. Yes, exactly. We actually are learning an AI framework called Pytorch. And we're training the AI, so the AI is also learning right now. This very moment. Not a little bit, all the way. Right there, you guys. It's learning right now this very second. Okay. All right, good to have you here. So we are going to do a no grad on the test loader. Images and data. Okay, good. All right, let's do this. This is the testing phase right here. That's all we need. Right here. Let's build the test, you guys. Let's build it. So we've got our test data. So our test data is in Lynette. Whoa. I'm actually kind of curious. Yes, that should be fine because where's our test data get loaded at? We could do a load test data right there. Oh, it already happens on initialization. Okay. So that should be fine. So we should have all our test data there. Perfect. Okay. So let's do our test. Lynette.no grad. I think we can do that. There's also inference mode at torch.inference mode, like this. I think we can do that right there. I think we can do that. I'm pretty sure. So we don't need to say no grad. We can just say inference mode. So we've got our safe tensor. We're good to go. Let's start testing it now. Okay. Let us try it. So we should be able to start testing this here. So let's see if it works. Do we do model 2? If we're loading the model, should the model, can we do model the net.to device like that, and then .to device, because we want hardware acceleration, because it's going to take a smidge. Return. So we only get one. We only need one batch. All right, let's see if it works. We are building a convolutional neural network in Pytorch. We are becoming Pytorch experts following every single tutorial available to us. We're building a model that does computer vision. Obviously, that's what you do with the CNN. It's meant for two-dimensional or multi-dimensional data, where you can take meaning between relationships between pixels as they are next near to each other. So that's what that convolutional part is. It's going to derive meaning about the neighboring pixels and their relationships. So if it's a 3D image, you can have like a little cube. If it's a 2D image, right? Usual photographs are 2D images. You can test the pixels around each other, and then you can start processing like things like circles or half circles. Oh, and then, oh, that's actually an eye, or now that's a person's face, right? That's what it is. And you made your own library? That's crazy work. Yeah, I know, right, Loons? A long time ago. Oh, gonna continue tomorrow when Neva. All right, sounds good. Have the attention to actually, because you don't know what you're doing right now. I know it can get overwhelming. It can. So let's see if it works. Is it gonna work? Is our test data gonna work? Is it gonna load? Okay, it's loading the data. Oh wait. Oh, did we not run? We didn't even run the test function. Okay. So load Lynette, and then we'll go test like that. So this is, wait. I suppose we could test it either way. It's going to be testing either way, right? So let's pull this here. Test, like that. Okay. Now we're going to get it. Here it goes, you guys. Oh, it worked. It worked. Okay, good. This is exactly what we're looking for. And good news. It's running on our hardware accelerator. All right. Perfect. That is so rare. I don't know if you guys seen, if you've been watching and following along, obviously, we usually get errors when we run. Yeah. It works. I know. First try that time. First try. We read this little bit of code here, and we're following along sort of with our tutorial. We're making it different. Obviously, look, these two, they don't look the same, do they? They don't look the same. We're following the tutorial. We're making them look a little different. Okay. So let's see what we got here. Let's see what we got. I want the argmax. All right, good. Yes, right there. So as you can see right here, this part right here, this is the middle one. This is the answers. This is where we did the argmax. So it says it's going to be number 8. It's going to be 0 and 7. What we could do is make sure that we should look at it too. We should look at it to see if it looks good. That's what we should do. Maybe what we could do is also do show images. Let's do show images. I want right here. Let's see if it gets it right. I believe the batch size is 64, right? No, it's 128. Okay. 100% yes. Are you guys crazy? Okay, we'll find out. CNN. Okay, here we go. Let's see if it gets it. You know what? Okay, here we go. All right. Did it get it right? All right, first one. Here we go. Are you guys ready? We're gonna strap in. Okay. So we're gonna have to take this. We're gonna take a look at this. All right. So the first one, it's a plane. That's definitely a plane. Did it get it right? Yep, plane. They're right here. Yep, plane. And that looks like a dog, or it kind of looks like a cow. To be honest, is that a cow? But I don't think we have a cow as an option. Let's double check. Is there a cow? I don't see one. It's just gonna be dog. So it's got to be a dog. That's a dog. All right. Next one. Deer. Yep, that's a deer. And the next one's a plane. We did a 100%. Check that out. We trained ourselves an AI model that got 100% accuracy. Look at that. What we need to do now is we need to compare all the answers with programming and test every single one. Now, there's probably going to be one or two that are not correct. If we get 100%, I'll be super surprised. If we get 100% out of every single sample. Right now, we just got really good, right? We just got lucky. We got lucky. Okay. So we've got our answers. We got our output. We got our labels. Let's do this. We're gonna rewrite this. So AI answers, and we're gonna say this one's on that device, and this needs to go .to device like that. I'm pretty sure that should do the trick right there. Boom. Let's see if we fixed it, you guys. Let's see if we fixed it. I'm pretty confident now. Yeah, there we go. Perfect. Okay, so that is on MP. I want it to... I wonder if we could do this... I wonder if we could do it differently. Because... do we want to? Do we want to make this a... Do you think what we could do is not have to do this? All right, we'll do macro. Okay, so... We've got our numbers and our classes. Looks good, 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 good. Target spreads. Perfect, perfect, perfect. Okay. So, we got our argmaxes. So we got answers and predictions. Let me figure this out. Like that, like that. Now we're talking. Now we're talking. Yes, yes. We're in the right spot now. Oh, we're gonna get it going now. Okay, so, comma. What was it called? Average. It's going to be we'll just do weighted. We'll do weighted. Average equals W-E-I-G-H-T-E-D. Weighted average. Average equals W-E-I-G-H-T-E-D. W-E-I-G-H-T-E-D. Perfect. Okay. All right, you guys. There we go. I think that'll do the trick. Wait. All right. Is it gonna work? Is it gonna work? All right. So no more errors. No more errors. No errors, you guys. Failure occurs when building the compiler. Uh-oh. I'm not gonna continue. Yeah, I know. Those compilers, they take a long time. All right, F1 score. Let's do this, you guys. You better work, F1 score. I'm working on to make you work here. Here we go. F1 score, F1 score. Work. Don't crash. Hey, we did it. F1 score. Oh, look at that. Yes, it should be. It's about 50%. Okay. There you go. F1 score. Right there. Let's do it again so it looks higher. The F1 score is 41%. Not very good. Let's make it, let's end it on a high. Oh, that's 50%. Okay. Not quite much of a difference, essentially. Let's go. We did it. Serendip F1 score. We got it. Okay. Nice. It's fixed. Exactly. I want to see 100%. Let's see if we can get one that shows 100. Let's see 100. Run for 185. All right. Getting close. 100 right there. All right. Hey, we did it, you guys. Thank you so much for joining. It was a lot of fun today. We enjoyed building our convolutional